I am Md Mazadul Islam, a PhD student at Western Sydney University. Before that, I did my master's from Wageningen University and Research, the Netherlands. And in 2023, I joined here as a PhD student under the supervision of Professor Jonghua Chan. My co-advisory committee members are also Adjunct Associate Professor Shamsul Huda, Dr. Lili, and Dr. Jinghe. My PhD project is on especially improving fertigation efficiency in high-tech greenhouse in the crops capsicum and eggplant, where I look how different fertigation doses influence the crops physiology, the quality, and the sustainability. In my PhD, I used 3 different doses of potassium fertilizer and evaluate the crop based on their physiological performance and the quality approach like post-harvest quality analysis and of course the multi-omics analysis, that means the metabolomics and transcriptomics. All of these things gives me a big portfolio of the PhD research that how plant is responding with these fertilizer doses. And the main thing that I'm tackling is actually optimizing the nutrition, but this thing, because nowadays high use of fertilizer is a big concern in protected cropping industry. And because of this, it increases the cost of production and also increasing the environmental burden. So we would like to find out a sweet spot where plant can give us more productivity with less resources and with sustainability. This PhD is expected the outcome that an optimized fertigation strategy that will increase our yield, and at the same time it will increase the nutrient use efficiency. But from a scientific perspective, we can say that we would like to understand how plants are response, their physiological trait, and which molecular pathway are coming up because of different fertilizer doses. That will be a benchmark for future breeding works in vegetable crops. And also from a practical perspective, we can say that we would like to deliver a evidence-based recommendation for the grower, for the industry partners, so that they can utilize in their cultivation system and they can get more from the less resources. This research is collaborating with Western Sydney University, Qatar University, and CRC Future Food System. The Qatar University and Western Sydney University are the research component, and CRC Future Food System is providing the funding for this research, which is not only enabling this research, but also they are strengthening the collaboration between the academia and the industry partners, so making the real world impact. This research can positively impact the agri-food sector by improving nutrient use efficiency, because it means that it will reduce the cost of production, it will reduce the food waste, it will reduce the environmental impact, and overall it will provide a good agricultural production system. So in this protected cropping and control environment agriculture, a small change in nutrition level can make a big difference economically and environmentally. My daily schedule is quite dynamic. Sometimes I'm busy in the greenhouse for measuring physiological measurements and also monitoring the crops. Sometimes I'm busy in the laboratory for other laboratory works. But a significant part of my PhD or the research I'm spending for writing manuscript and also multi-omics data analysis, especially the transcriptomic and metabolomic data. So you can say this one is a hands-on practice and balance between hands-on practice and data analysis. I'm hopeful about this research for the future food production, because nowadays we have advanced tools and techniques like high-tech greenhouse system, precision fertigation management system, and also combined with molecular tools, which all of this helps us to understand the crops better. And by integrating science and the modern agriculture, we can get more from the less resources in a sustainable way. In future, I would like to continue my future with plant science and sustainability research, either in academia or in industry. But my long-term future goal is to develop an efficient production system that will meet the global food demand under the changing climate condition.